evening, ladies and gentlemen, boys and girls. Welcome to Science Center Singapore. And of course, to our night sky, our live broadcast, Astronomy 102. Now, because of the COVID-19 situation and you can't really go out to see the night sky, the best way to see it is actually in the comforts of your own home, brought to you by Science Center Singapore and, of course, our observatory. All right, so here it is. Okay, we're going to show you a little bit about the night sky. And, of course, using this software called Stellarium. So perhaps let me turn on Stellarium over here so you can have a look at the night sky. Okay, now look over here. Wow, look at that. Now, if you don't know already, if you look down below at the mouse over here, this shows a little bit about what we call the cardinal directions. Now, we're generally looking in the southern directions. Now, there's a group of stars I'd like to show you in the south over here. And this is it. I'm going to zoom in a little bit closer. Now, there's around 4 stars over here that forms a particular shape and pattern. Now, obviously, we all know that this is called a constellation. Now, this is the constellation called the Southern Cross. And down over here, you might notice it points towards the south. So look towards the south, and you might see this if the sky is clear tonight. Now, from the southern part of the sky, we're going to focus once again, turning towards the right-hand side, towards the northern part of the sky. Now, you can see there's Canopus, the second brightest star in the night sky. And down over here, we have Orion, okay, the constellation of Orion. Perhaps we should talk about that slightly later. And now over here, we focus towards the northern part of the sky. And the group of stars I like to look in the north is down right over here. There, can you see that? Let me zoom in a little bit closer over here. 7 stars, 1, 2, 3, 4, 5, 6, 7. Now, these 7 stars forms a particular shape and pattern we call an asterism. This is called the Big Dipper. And the Big Dipper, of course, it points towards the north over here. Now, down right over here where it's pointing to, it points to this star called Polaris, or sometimes called the North Star. Now, you've seen, right, it's actually part of a larger constellation called Ursa Major as well. Now, of course, if I were to show you the night sky again, like I did last week and 2 weeks ago, it's kind of boring, isn't it? So today we have a very special guest all the way from Manila, Philippines. His name is Pecier. And so from here, right, in Singapore, we're going to fly over to Philippines, Manila, and perhaps we just wait right over here. So here we go.
Hi, hello, Young.
Hey, Pecier, I can see over there. How is it in Manila, Philippines?
In Manila, it's pretty humid and hot. I guess it's the same in Singapore.
Yes. And here is it. Is this the sky in Manila over there right now?
Yes, this is the sky in Manila. By the way, good evening to you and to our viewers online. Thank you very much for inviting me, Young. Thank you to the people there over at the Science Center Singapore Observatory for inviting me. My name is Pecier. As Young has mentioned, I am a science communicator from the Mind Museum in Manila, Philippines. Have you visited Manila already? Have you visited Manila before?
Well, I have visited the Manila one time actually, and of course I visited the Mind Museum. You have a very nice planetarium as well, which I've seen some of the shows over there and look at some of the exhibits. So yeah, so this is the sky in Manila. It looks familiar to me for some. It looks the same.
It does. It does. Yes. So if our audience is astute, they will notice that we see a similar star pattern here, as Young has shown. You can see it in Singapore. We can also see it in Manila, and it's called the Big Dipper. So the Big Dipper, as Young has pointed out, right, points directly to the north. But here in the sky in Manila, look where it points. It points to a star, and that star is to the north, right? And that's why we nicknamed that star the North Star. Yes. Young, what is the official name of the North Star again?
Oh, I think it's supposed to be Polaris.
Polaris, yes.
Yeah.
So, pole star, right? Mm-hmm. Yeah, so Young, is this star Polaris easy to see there in Singapore?
Well, almost impossible for us to see. So just now, even under the best of conditions, using a simulated software, it's down right below the horizon, blocked by that bunch of trees over there. So in Singapore, of course, we have taller buildings and all these things. So it is, well, impossible for us to see Polaris. Oh, I've never seen it before, at least.
You see, from the sky of Singapore, at least.
Yes.
Why is that?
Well, Singapore.
How high is it?
Well, Singapore is technically 1 degree north of the equator, just tiny little bits above. So technically we should be able to see it, but like I've said, right, all the tall buildings will block our point of view as well. So yeah,
I see.
can't
So
see.
Singapore is about 1 degree
Yes,
north of the equator.
that's right.
I see. And therefore, Polaris is also about 1 degree above your horizon.
Think about that.
I
Can't see,
see.
right?
Well, that's really small. Yeah. So we here in Manila, we're approximately 14.5 degrees above the equator, north of the equator, which means Polaris, the North Star, is about 14.5 degrees above the horizon. So that's a little bit
Yeah,
higher
just a little
than
bit higher.
1 degree. Yes. So, and therefore easier to see. So that's what we have here. So that's really interesting. We can actually look for the North Star, right? When we're in a different
Yeah.
part of the world, if you're north of the equator, find the North Star. And then if you can estimate how high it is above the horizon, you can tell how far north you are of the equator, a term we call the latitude. So the latitude of Manila is approximately 14.5 degrees north. Now, how do we measure angles in the sky?
Oh, I know,
Like
I
what
know.
kinds of tools? Yeah, what do you use, Young?
Well, navigators in the past, they used to have this instrument, right, that kind of measure the angle like a giant protractor called a sextant, isn't it?
Yes, that's right. So a sextant is a pretty cool kind of yeah, like a protractor that you use to measure angles in the sky. It's really cool. I've seen one in a museum in the
Yeah.
United States. It's made of metal, a recreation of those old timey ones. But do you know that you can approximate or estimate angles in the sky using a very handy tool?
A handy tool,
Yes, a handy
protractor.
tool. No other than your hands.
Oh,
So
my
I hope that, of
hands.
course, yes, I hope that you are, of course, all washing your hands with
Yes.
soap and water for at least 20 seconds. And with your clean hands, you can estimate angles in the sky. For example, if you try to add up your fists, right, your closed fists, all the way from horizontal to vertical, you would notice that you can make about 9 of them. So you add up 9 of your fists from horizontal to vertical. So Young, remind our audience, how many degrees again does it go from horizontal to vertical?
Oh, from horizontal to vertical,
To vertical, yeah.
that will be about 90 degrees.
90 degrees, that's right. So we divide 90 degrees by 9, which means your fists measure approximately 10 degrees of sky. But remember, you should hold it at arm's length, right? So that it's not so close, not so far, at arm's length. After all, we humans have a certain proportion to us. So if you have big hands, you usually have longer arms. Or if you have small hands, you usually have shorter arms, and that compensates for it. So for us, a fist is about 10 degrees of sky. And then if you want to measure smaller angles in the sky, you can use your fingers. For example, your pinky, like there. So your pinky measures about 2 degrees of sky. And here's one really curious thing about this. It's always bigger than the full moon. Have you taken a photo of the full moon, Young?
Oh, well, Pisha, it's really hard to take a nice picture of the full moon. It's too bright
Yeah,
to
too
take a
bright.
picture.
But how
Yes.
about using your phone or an SLR, not using a telescope?
Oh, not using that. Well, of course, I have taken pictures of the full moon
Yeah.
before.
Does it look as big as in your head?
Well, not really. It looks really kind of tiny, actually.
Yes. I mean, that's because, of course, when we look at the full moon, when it's close to objects in the horizon, like trees and buildings, there's an optical illusion called the moon illusion that makes it appear bigger psychologically to us. But actually, the moon is not so big in the sky. It's about half a degree in the sky. And remember, your pinky is approximately 2 degrees. So don't take my word for it. Try one when you can see the moon in the future. A full moon, even if it's what they call a super moon, which is a larger than usual full moon, try if you can cover it with your pinky held at arm's length. At arm's length. That's how small the moon is, which is why, as Johannes pointed out, many of us get disappointed when we try to take a photo of the full moon using our cell phones. It looks tiny than we expect.
Mhm.
Yeah. All right. So, and then there are other ways to measure it. Like, for example, you go from pinky to your middle finger. That's about 5 degrees. And then you could try your hand span. So this one is about 15 degrees. And if you extend it, it's about 25 degrees. So next time you are in a different part of the world, And especially if it's north of the equator, you can see the North Star. Try to measure how many degrees the North Star is above the horizon using your hands. And how many degrees it is will be about the same as your latitude, how far north you are of the equator. So, Young, you showed us earlier a constellation, the first one. What was it
Oh
called?
yes, that was the Southern Cross over there. That
The
was in the
Southern
southern part of the
Cross. Okay,
sky.
southern part of the sky. So, speaking of southern part of the sky, let's
All
show
right,
our
let's show over
audience
there.
what the southern part of the sky in Manila looks like. All right, so it's gonna be similar but slightly different.
Oh, I
Right.
see.
Can you see the Southern Cross, Young?
Yes, I can see, but it is a little bit lower than what we usually have it in Singapore. Well, at this time of the year.
It is. And in fact, it is lower every time of the year. The highest it can get is only up to here. And this is the window of its movement in our sky. So we see it for a shorter window of time here in Manila compared to you in Singapore. So although we see the North Star better, it's easier to see the North Star here in the Philippines. It's more difficult to find the Southern Cross.
Mhm. All right, let's have a look at the Southern Cross here. Now, the thing about the Southern Cross, right, there's something that we usually like to have a look at it as well. So
Yeah,
last time
so
when we operate the telescope, we always tend to look towards this star to the left, that's Mimosa over there. And just
yes,
down slightly below, there is what we call a star cluster.
yeah, and I believe, Young, you have a photo of that taken of that star cluster that you will show our audience here in the
Well,
Philippines.
perhaps later at the end, right, we
Yeah.
can show it to them. But
So
we can
here
show it
about.
here.
Yeah.
Yep.
Okay. So
So
we can
to our
show them
eyes,
brief.
right,
Yeah.
it
All
almost looks
right.
like an A shape over there. See that?
Okay. So please show us a picture of this group of stars later, Young, and tell us more
Yeah,
about it. Right.
definitely. Mhm.
Yes. Okay. So that's close to the Southern Cross, called the Jewel Box, right?
Yep.
Okay, so Young, I've been asked by our good friends there to talk a little bit about how to get into stargazing, right? So I'm invited here to share more about stargazing as well.
Yeah.
So I got into stargazing, like most of people who are fond of stargazing, by doing one thing first, right? Which is observing the sky with just our eyes. So that is my first tip to those who'd like to do stargazing, and it's use your eyes. So don't rush to buy a pair of binoculars first or a big telescope, which might be expensive. My tip to those who'd like to go into stargazing is first just use your eyes. They're really the best instruments we have for stargazing, especially as beginners. And then another great tool that we have, of course, are our gadgets, like our cell phones, the smartphones especially, and our computers, which have these awesome software which we can use in order to be familiar with the basic constellations. So, Young, do you see a lot of stars there in Singapore?
Well, unfortunately, in Singapore, because of the light pollution, it is really hard for us to see the sky. Not, it doesn't even look as nice as this actually. So yes, light pollution. I imagine the situation is the same as in Philippines as well.
Yes, it's similar here in Manila. We have also lots of light pollution, so we see fewer stars. But actually, Young, there's a slight advantage to
Is it possible to have a better sky, to have less stars out there?
yeah.
Actually, want more stars, right?
Of course, you want more stars, right? But if you see fewer stars, for example, because you live in the middle of the city,
Mhm.
then it will be easier for you to be familiar with the basic shapes of the constellations.
Oh,
For example, it's easier to look for the Big Dipper, or it's easier to look for the Southern Cross. Young, have you been to a place where it's really dark and you see so many stars?
oh yes. I now that you have talked about it, it reminds me last year in November I was in Nepal looking at the night sky, and it
Oh,
does confuse me quite a lot when there's just so many in the sky, saturated with stars in the sky. I look at the Leo the Lion, and I couldn't even believe what I was looking at.
yeah.
You have to squint your eyes into narrow slits and look up there so that only the brightest star will shine up, and that is how you recognize well the brightest constellation. So yeah, so
Yeah, that is
yes,
true.
light
Yes,
pollution can help you.
can have a slight advantage. Yes, of
Yeah,
course,
slight
we want
advantage.
to have less light
Mhm.
pollution. And good thing that many governments around the world now are taking steps to address that. But while they're still there, it's still there. There's a slight advantage in that it's easier to look for the constellations like the Big Dipper, which is an asterism, as Young has pointed out. Asterism is just a name that we give for patterns of stars that are not one of the official constellations. And then, of course, there's the constellation of the Southern Cross. So that's one tip I have. Just use your eyes and don't buy any fancy tools yet. But if you'd like to start with a tool, again, the best tool would be just your eyes and smartphone. But a pair of binoculars would be really great because a lot of the really wonderful things that you can see in the sky can actually be seen by a good pair of binoculars. And another tip, if you happen to visit here in Manila, or for the viewers who are in the city, when again the restrictions for social distancing have been eased up because we've contained COVID-19, then one tip I can give is just move a little bit far from the city here in Manila so that you can see more. So one place that I'd like to recommend to everyone, especially to you, Young, when you visit
Okay.
here, when you visit Manila in the future, would be a place we call Tanay, the town of Tanay, Rizal,
Nice.
in a
Okay.
nearby province. Yeah, just a couple of hours away from Metro Manila. And then you'll see so many more stars there. You can even see the Milky Way galaxy
Wow.
during the, well, weather permitting and during some of the year, like May, March, April, May. Those are the good times of the year to see it.
You know what? When I go over there, I'm going to make you bring me over there to have a look.
Okay, yes. All right, so I surely will. So, one last tip that I can share our audience, if you want to start stargazing, is to do, well, two last tips. One is to do a little bit of star hopping, and the other one is to familiarize yourself with some of the stories and myths behind the constellation. So, here's one of my favorite myths. It's from a Greek story, a Greek mythology, right? So already it's 8:18 here in Manila. So the constellation that I'd like to show you has already set, but I'd like to make it a little bit earlier, an hour earlier, right? This was
All right.
7:19 earlier, and you can see this constellation is still up, right? I believe, Young, it's one of your favorites.
Yes, it is one of my favorite. It's a favorite of everyone in Singapore probably because it's so obvious. Yeah,
Yeah,
you
it
can
is
see the.
indeed.
Yeah.
So one wonderful thing I like about this constellation, the constellation of Orion, right, is that it's really storied in that, for example, when you see the constellation Orion, named after the hunter, so I'll just show the imaginary shape that the Greeks see it to be. So that's the hunter, right, with Betelgeuse in the armpit, right, and Rigel as a foot. So that's your hunter Orion. Okay, so again, that's just an artistic rendition. So, what the wonderful thing about that is that there's this Greek story where Orion is mortal enemies with a great scorpion, right?
Ah,
And
yes.
so, yeah, and so the Greeks have come up with this story because at the opposite side of the sky as Orion is another constellation that I think is also a favorite of yours, Young.
Yeah, Scorpius.
Yes. Why is it a favorite of yours, Young?
Well, the thing about the Scorpius is got this super bright reddish colored star within its heart called Antares. And of course, they actually kind of like on opposite side of the sky. So when Orion is up, Scorpius will be disappear. When Scorpio is up, Orion will
Yes.
disappear. And it's a
So you
good
never,
way.
yeah, that's right. So you never see them in the same sky at the
No,
same time.
yes, and it's
Yeah.
a good way to explain this idea, where with how the Earth goes around spins on its axis and things like that. Yeah.
Yes. And of course, yeah, that's right, Young. It's important to remember that this apparent motion of Orion and Scorpius is just apparent. They just
Hmm.
appear to move. It's really the Earth that's moving, right? The Earth is moving in two ways, as you've mentioned. It's spinning about its axis, we call rotation, and then it's moving around the sun, we call revolution. And because of these two kinds of movements, we see the constellations seem to move ever so slightly across the night. Like, for example, we saw Orion up earlier this evening, but right now it has already set. Um,
Yes.
yes, and once it sets, Scorpius is already beginning to rise in the opposite side of the sky. And this apparent motion is again because the Earth is spinning or rotating. So let me
Oops,
just make it a little bit later. There you go. So there is
yeah,
Scorpio.
Scorpius over here.
Yeah. The wonderful curve. I also like it because of its shape, so elegant. Not many constellations actually look like the thing they're named after.
You
The
know,
Scorpio. Yeah. Go ahead, Young.
recently I had a talk actually. I did a planetarium show, and one of our students called it Maui's hook.
Oh
You know,
yeah.
from the movie Moana. And
Yes.
later I discovered that the Polynesians actually recognize it at Maui's hook.
Indeed, yes. That is a wonderful. That's another thing I like to point out in my shows in the planetarium. I always ask people, "Hey, have you seen the Disney film Moana? The shape there, Maui's hook, is actually a real asterism used by the Pacific Islanders, right?
Mhm.
Yes, and they have a story behind that as well, a different story from the one used by the ancient Greeks. So, if you're familiar with these stories, it's fun to look at the patterns, and it also makes sense what their motions are sometimes. So, that's my second to last tip. A part of that tip, before I go to the last tip, is to familiarize yourself with the local stories. And Young has already pointed out one local story, for example, Maui's Hook. Let me just go back to that other constellation that
Mhm.
has already set. Let's
All
go back
right.
to Orion. Yes.
Yeah, I know you have a story about that. It used to be
Yes,
in Philippines used to be something, wasn't it? Like a trap or something.
indeed. The interesting thing here is that in the Greek stories, Orion is a hunter, right? In the Philippine stories, before the Spaniards arrived, it is called the hunting trap. Their word for it is balatik, hunting trap, because their hunting trap, right, included three sticks to the ground with a string tied. It's a trap for boars usually. So a hunting trap. So really interesting that both in the Philippines and in Greek culture, very far apart, these group of stars are associated with hunting, right? The hunter, a human hunter in the Greek story, and it's a hunting trap in the Philippine story. But when the Spaniards arrived and they introduced when the Spanish arrived and they introduced Christianity to the Philippines, and many Filipinos converted to Christianity, they began calling this by a different name. Right? So, Young, around what time of the year does this begin to show up again? Because right now, here in May, it sets pretty early, right? So we don't see Orion so much. When in the year do we see it a lot again?
Well, in Singapore, it kind of usually appears early in the year in January, or perhaps you might say late in the year in December. It starts
Yeah.
to rise in Singapore.
Yes, so it's the same here in the Philippines. It shows up right around
Mhm.
December and January too. And that's why many Filipinos call them the Three Kings.
Ah, the Three Kings.
Yeah, the Three Kings after the story in the Bible.
Yeah,
Yeah.
I've heard
So
of the Three
another,
Kings.
yeah, that's right. And another name that Filipinos call them would be Tres Marias, the Three Sisters. Right. So now let me go to my last tip. My last tip for those who'd like to get into stargazing. So after you use your eyes with some simple tools, and then you do some familiarization with the stories, both the Greek stories and the local stories. Another wonderful thing that you can do would be what we call star hopping. So Young and I like star hopping so much, of course, because we like stargazing, right, Young?
Yep, that's right, of course.
Right. What's one way we can do star hopping here from the belt
Well,
of Orion?
from the belt of Orion, if you fold the belt backwards, it points to a very bright star. In fact, that star is the brightest star that we can see in the night sky, called Sirius.
Sirius,
And yeah,
yes.
Sirius. And I usually say in terms of a story, because Orion is a hunter, and
Mhm.
what follows after a hunter but a dog. So we have
Yes,
a
a dog.
Canis
Indeed.
Major,
Canis Major, the big dog. And of course, he's a hunter. He has two dogs. He has a small dog right here, right?
Procyon.
Yeah, precise. So Canis Minor, the small dog, or as I like to talk when I talk to young audiences who like to go on the internet a lot, I like to call this big dog the dogger, and this one is the pupper, which is what people on the
Oh,
internet call dogs and puppies, dogger and pupper of the hunter. So they all ended er. So yeah, so that's Sirius the Dog Star, which is also the name of one of the characters in a famous novel by J.K. Rowling, right? A series of novels called Harry Potter. And Sirius turns into a dog in that story. So the author of Harry Potter, J.K. Rowling, is actually fond of astronomy, and she has lots of tidbits related to astronomy in her story. All right, so that's Sirius, and from Sirius, you can actually go to a few things that we will show later. So, Young, I believe you will show us later photos of something close to Sirius, right?
Oh yes, there's a deep sky object very close over there. If you can zoom in slightly to Sirius, just a little bit below within the chest part of it. That's actually what we consider a deep sky object. Closer
Right.
even. Yep, right over here.
How about
Oh, I can.
what is that one?
Oh look, what's that thing moving over there? My goodness. Well, what do y'all think it is? Well, I think it probably
Yeah.
is a satellite, isn't it?
It probably is.
Probably
And
is
the
a
wonderful
satellite.
thing about this software, Stellarium, is when you click on objects, right, it'll tell you what kind of satellite it is, right? It
Okay.
informs you. All right, so this is the object, and Young, you will show to us photos that you've taken from Singapore, right, of
Yes.
this object, and we will talk about that again later. So
Yep,
from
that is.
Sirius, you can go there, and all right. And then if you go back to the three stars of Orion's belt. Below it, you will find another deep sky object, right, Young?
Yes, that is, if you look somewhere between his belts, where we will hang his sword over there, at the end over there, there is this faint cloudy-like object. If you look over there, that is called the Orion's Nebula.
Orion Nebula,
Yeah.
yeah, that's right. So let me just zoom in a little bit, right? So we will go back to this later, right, Young?
In fact, we'll talk about
Yeah.
all these things,
We'll
of
talk
course.
about that later. So let me zoom back to that later. Let's circle back to that before we end the show. But I'll just like to show you one more really wonderful shape in the sky that's easy to use to do star hopping, right? So that would be the Big Dipper. We're back to the Big Dipper,
Back to the
right,
Big
Young?
Dipper again.
Yeah.
Yes.
So earlier, Young showed us how to use it to look for due north and the North Star Polaris. But we can also use it to look for other shapes in the sky. I really like this shape a lot, right? In the part of the Philippines where I'm from, we call this losong, or it's like a mortar where we grind our corn and rice. So that's the dipper. This is the handle, right? Or that's the handle of the losong, we call it. All right. So if it's a dipper, Young, and it is a hole, where would it leak?
Oh, the water will leak upwards.
Yeah, it would leak up, right? That it would leak up. So we say that the Big Dipper leaks to Leo. That's Leo right there,
Ah,
right? So let's add the art, right, to help the audience imagine what the lion is, with the Regulus, the heart of the lion, right? And here, Denebola, the tail of the lion. So that's Leo the lion, where we can see a meteor shower. It seems to spring out of Leo during November, right? So that was what we call the Leonids meteor shower. Have you ever watched a Leonid meteor shower, Young?
well, yes, I have. I waited for several hours, and originating from Leo the lion, we could see perhaps one or two bright flashes
Yeah.
of light, and that's it.
Yes. But will you only see it in Leo, Young, or do you see it everywhere in the sky?
Well, mostly originating somewhere around Leo the lion. That's why we
Yeah.
call it the Leonid, but
The
it's
Leonids.
kind of
That's right.
flashing around.
Yeah. So you can see it anywhere in the sky, but it originates from Leo, right? It
Yes.
seems to originate from there. And they're actually parallel, right? So it's like when you draw parallel lines from a distance, they look like they come out from the same point, right? But actually, like when you're drawing, for example, a rail, right, of the train, the tracks of a train, they seem to zoom from one point, but actually they're parallel. Same with the meteors in a meteor shower, right? So that would be the Leonids. So that's one tip. You leak to Leo, and then
Big
if you look at the
Leo.
handle of the Big Dipper, is it straight, Young, or is it arced?
Well, it's kind of like a curve, like a cobra.
Yeah, that's right. So it's arced. So we say it
Points.
arcs. Yeah, it arcs to Arcturus. That's that star, Arcturus, in the constellation Bootes, right? Or
Clever.
Bootes,
Yep.
Bootes. And then you speed on to Spica, or you spike to Spica. So Spica is like the laurel leaves held by the lady in the constellation Virgo,
Mm-hmm. All
right?
right.
So
So
that would be my last tip for star hopping. So do some star hopping when you begin as a stargazer, because then it would be easy, and like the star patterns would be almost like your friend, you'd be familiar with them. All right, so
Yeah.
I promised our audience that we will end here. We will go here rather, right, before we move on to the next step. So we're back in Orion with
Back in
Orion's
Orion.
belt. Yeah. And below Orion's belt, what do we have again, Young? Can you tell us
We
a little
have
bit more?
somewhere over here Orion's Nebula, the beautiful Orion's Nebula.
All right, there you go. Okay, so I believe, Young, you have a photo of the Orion Nebula and
Oh,
other objects, right, deep sky objects taken by your colleagues there in Singapore.
all right. So they took the pictures yeah, a couple of weeks ago actually. So let me look through the files and so we can show you how the images of Orion Nebula look like. Oh, there it
Yes.
is. Okay, wow, look at that. That's the
Oh, it's
Orion
sorry.
Nebula.
Is it already up? Okay, it's up. All right. Okay, can you show me the pictures, Young? All right.
There it
Wow.
is.
Oh, wow. Wonderful.
So you can see that this, of course, in the real life, if you try to see Orion Nebula with your naked eye
Uh-huh.
through a telescope, it will never look like that. It looks more like a blobby, whitish, greenish kind of a blob over here. So this is taken after a very, very long exposure, of course, and show that the colors can reveal itself.
Well, what kind of telescope do you have, Young, that can take up a photo of the Orion Nebula to look like that?
Well, we have a 40 centimeters, the aperture of the telescope, which allows the light to enter. And yeah, and of course, this is taken after a very long exposure as well. And I believe, right, these images might have been digitally enhanced as well to deepen the contrast between the colors so it looks much, much better.
Yes. So with our telescope in the museum, we have a 6-inch and an 8-inch telescope. So whenever we describe a telescope, like what Young did, the number that we are describing would be the size of the telescope, called the aperture. That's the opening, which is a measure of how well the telescope can gather light, which is really the best measure for a telescope. So it's not magnification. Unlike in other telescope, they're often described in terms of magnification for a telescope. Actually, the best way is by its size, right? So with our 8-inch telescope in the museum, Young, we can see this too, but it looks like a white smudge in our telescope.
Yes, I believe in most normal cases, even when we take an image, it does look like a white blob over there. So like I've said, this is probably digitally enhanced as well. Oh, and if anybody
Yeah.
is interested in astrophotography, I believe
Uh-huh.
the Say Yes group, they are doing a podcast as well about astrophotography. So after this, you might like to have a look at their videos as well. It is Say Yes, Sayes.
I see. So can you tell us a little bit more about this
Or
cloud that we are looking at, Young?
well, it is the Orion Nebula is quite large actually, measuring around 26 light years across, and it's mostly formed from hydrogen gas. So if you don't know already, right, stars themselves are formed from hydrogen gas, and in a way, right, we believe stars were formed in nebulas such as this as well, like in Orion's Nebula. And if you look right in the center there, you can see these bright flashes of light.
Mhm.
Those are the newborn stars that were formed within these nebulas as well. As the gas starts to condense together, pull together by gravity to form themselves into star systems like our solar system,
I see. Wow.
newborn stars.
So newborn stars, yeah, that's right. So when Young says newborn stars, that means those stars are young, right? But well, here's the amazing thing: when I tell you the age of the star, you'd think it's old, right? It's up some millions of years old, like around 3 million years old for most of those stars, and that's actually really young. But 3 million years sounds like a lot of time, right?
Yeah, of course. When we talk about in cosmic scale as well,
Yeah.
and just for your information, when we look at the nebula over here, Orion Nebula, it is about 1,300 light years away from Earth. So that means the light from those stars, from these nebula, took 1,300 years to travel through space and reach our telescope that we took and showed over here.
Right, well, that's amazing. So again, it's 3 million years old, but in comparison, for example, the sun is 4.6 billion
Yeah.
years old, right? So compared to the sun, the stars in that nebula are babies. That's why
Babies, yeah,
another,
newborn
yeah,
stars.
That's why another nickname we have for nebulae, like the Orion Nebula, is they are nurseries for stars.
That's true.
Right, yeah. And they're baby stars. And it looks small right there. And especially if you look at it in a telescope, it occupies a small span of sky, but it's actually pretty large, right? Like Young mentioned, thousands of light years across. To give you a comparison, 1 light year, by the way, is the distance that light travels in 1 year. So that's a very big distance. Now, the distance from the sun, 6 light hours. So it takes light from the sun to Pluto only 6 hours, right, to travel. But that thing we're looking at, that our good friends at Singapore have taken a photo of, is thousands of light years across. That is really amazing to me.
Yeah, imagine several solar systems stacked across each other, and you might have an idea of how big it is.
It
Yeah.
is.
All
Can
right.
you show us a few more pictures,
Oh,
Young?
yes, of course. Let us try to change to show us. Oh, there is another thing. Remember, we had a look at the Canis Major just now, somewhere near the chest part over there. That is a cluster of the stars, okay, that were formed within a nebula, such as we saw earlier. And still, right, they kind of remain close to each other, but eventually, over the millions and billions of years, they'll slowly drift away back out into the Milky Way galaxy, into whichever corner of the galaxy they occupy.
Yes. So this is called a cluster of stars. It is an open cluster, right? That means that the stars that are part of it, of that cluster, were more or less from the same stellar nursery, and they're loosely bound by gravity, and that's why the shape is not so regular. If you compare it to, for example, globular clusters, which are tightly bound by gravity, they're really, really round in shape. But these ones, they look more or less loose in shape, irregular in shape. So that's what we call an open cluster of stars, the little beehive cluster in the chest of the dog. So, Young, have you tried to show your audience there, like what would happen if you turn your telescope to a cluster and then you turn it slightly to one direction?
Look at the cluster of stars
Yeah.
and turn it slightly in one direction. Well, the thing is, right, when we look at the cluster of stars, firstly, it's really, really hard to find. So it only occupies a very tiny part of the sky. So if you move it away, right, we'll be looking into an empty space and you will see nothing, okay, blackness. So people, they tend to think, oh, when you use a telescope to look out into space, you see things like that everywhere. But that's not true, actually. Yeah, that's not true.
Yes.
Space, our universe, is mostly empty.
Yeah. Yeah, that is true, Young. So that's something that I've experienced myself in the museum when I started learning to use telescopes. And I help people use telescopes. So a lot of people sometimes buy telescopes. So it's their first time to use it. And they discover, like you mentioned, Young, that if they point their telescope in a random direction in space, it's really going to be mostly empty. And they think, hey, maybe my telescope is not working. Why is this all black? And if you aim it anywhere, most of the time, it's just going to be all black. It's hard to aim it at a part of space that is going to have something. So when you turn it to a cluster, it's really quite surprising and pleasant to look like this one.
Mhm.
Yeah, can you show us, Young, more pictures that you've taken there?
Yes, let's have a look at more things over here. Oh, that's the heart-shaped cluster. So this is another cluster of stars, okay, somewhere situated between Sirius and Procyon, the little dog over there. So this is what we call the heart-shaped cluster. So this again is once again another cluster of stars, okay, out there in space.
Wow, that is a pretty cluster of stars, Young. Yeah.
This one is about 5.9 light years across, and it's about 3,000 light years away from us.
I see, yeah. And it's also a little bit young, older than the stars in the Nebula of Orion. Because, of course, in the Orion Nebula, they're still in their nursery, right?
Yeah.
They're really babies. Here, they've started to move a little bit further away from each other. So they're around 140 million years old, but they're still bound together. And eventually, they'll move further and further away from each other. But we know that they were born at around the same stellar nursery, because when we look at the light from these stars, the fingerprint in the light, right, the spectrum, what scientists call it, is similar. So they'll have a similar composition and they'll have a similar age. And that's how we know that these stars are sort of sibling stars, right? And now they're in a loose conglomeration, which we call an open cluster, right? Do you have any more pictures for us,
All
Young?
right, so let's have a look at more things out there. So that once again, this is the beehive clusters in Cancer. So just now we didn't have a look at the constellation of Cancer. It's very dim in Singapore, even in Manila, you can't see it. But anyway, right, this is a cluster of stars somewhere within Cancer. And the amazing thing about these beehive cluster was that it was observed thousands of years ago by this guy named Ptolemy, more than 2,000 years ago in the city of Alexandria. So they had very good eyes in those days, I think. Yeah.
So did Ptolemy use a telescope, Young, to see it, or
No,
no?
of course, that was before they had telescopes. Yeah, and he saw this bunch of clusters actually somewhere within what he called the breast of Cancer, the crab over there. And can you imagine that someone could actually see so far away? That is,
Amazing.
yeah, that was really far, 577 light years away.
Amazing, yeah. And the amazing thing about this cluster, what I really like about it, and why it's a favorite of beginning stargazers, is that it's relatively easy to find. Like you said, Young, it's in the heart of the constellation Cancer. From what I've observed here in Manila, the stars of the constellation Cancer are not easy to find because they're not the brightest.
Yes.
So what I often do to look for the beehive cluster is I look for the heart of Leo the Lion, which I showed earlier, Regulus, and I look for the two stars called Castor and Pollux of
Castor
the
and Pollux.
constellation Gemini,
Gemini.
yeah, which is just slightly above Orion, which I showed earlier. So if you go slightly above Orion, you'll see Castor and Pollux there. So if you draw a line connecting Castor and Pollux with Regulus, about halfway between them would be the beehive cluster, which is, as far as clusters go, actually fairly large in the sky. So remember when I told you how big the moon was in the sky? It is always smaller than your pinky held at arm's length. And again, don't take my word for it. Try that experiment. Every time you see a full moon, try if you can cover it with your pinky held at arm's length, and you'll be surprised that even though the moon looks big, it can be covered. Now, the beehive cluster is actually 3 times as big as the full moon. 3 times as big, but not as bright, of course, because it's diffuse, right? As a source of light, it is not a concentrated source of light. Well, of course, we know that the moon just reflects light from the sun, right? But at least it's in that small area reflecting light from the sun during a full moon. But here, the source of light is more or less diffuse over a region of sky that's about 3 times the size of the full moon.
Oh, no wonder it could be seen 2,000 years ago by
Yes.
Ptolemy in Alexandria, Egypt.
With their naked eyes.
Yeah,
Yeah, do you
it's
have
a
any more?
desert.
Yes. Do you have any more shows for us? Pictures for us?
Oh yes, we have this here. This is after Carina over here, and this is a very very large, how to say, nebula over here, super large actually. But one very cool thing about this nebula is that somewhere within that, you see that little mushroom thing over there?
Huh?
There is this after Carina over there. You see that little bit of mushroom? Now, there is a star that's gone supernova a long, long time ago, thousands of years ago.
Wow, so supernova, so it exploded, right?
It exploded.
It exploded, yeah. So in one of its most recent eruptions during the 1800s, that star Eta Carina, it's not so bright nowadays, right? But during that most recent explosion, astronomers have recorded it growing really bright, as the star Rigel in the constellation Orion, which you saw earlier, was fairly bright. It was the foot of Orion, right? So that star became really bright for some years and then dimmed, and now it's not one of the brightest stars in the sky, but it's really interesting because it's surrounded by a smaller nebula, right, called the Homunculus Nebula, like an ant-shaped nebula, and it's one of the most intriguing objects for astronomers in the sky. So, Young, you've mentioned that whole thing is really big, right?
Oh,
like
yes.
Just a few light years big. How big?
It stretches around a few thousand light years across, actually.
Amazing, thousands of light years across.
400 light years across.
Wow.
Yeah. So it is one of the largest nebula, like you have said, like you have mentioned with the beehive cluster. It also occupies a very large part of the sky within, the constellation of Carina over there. So this is definitely quite a nice looking nebula. seen it
It
before.
is. Yeah,
But you know what?
yeah, go ahead, Young.
When we talk about the supernova, right? When you say this happened about 200 years ago in the 19th century, but
Yeah.
last year, you remember when they talk about Betelgeuse,
Yes.
about it being dimming and all these things.
Yeah.
Yeah, a lot of astronomers believe, right, that Betelgeuse will eventually undergo somewhat of a supernova as well. Nobody knows, perhaps 10 years or even this year, but unfortunately,
Yes.
it didn't happen.
It didn't. Yes,
Yes.
we were many of us were anticipating it. Like we're really curious why is the star dimming. And I often when I do my shows in the planetarium, I tell them, look at Betelgeuse right there. It looks really bright, but in the real sky, it's not as bright anymore.
Mhm.
Something might happen to it, but as you said, Young, it did not happen. What happened to Eta Carinae during the 1800s did not happen to it.
Yes.
Yeah.
Otherwise, it would
At
be
least,
beautiful.
yeah. At least not yet. But I said earlier that the star in Eta Carinae, the star Eta Carinae, that's the name of the
Mhm.
star, well, became really, really bright. It's actually still really bright right now. It's not the brightest in our sky, but it's still really bright right now. The two stars in that system in the middle are actually really bright. Like the brighter among them, called the primary by astronomers, is about 5 million times as bright as the sun.
Wow.
Its luminosity, the amount of light it produces, is 5 million times. And the dimmer of them, the one that casts a shadow in front of the brighter one, is still, even though it's not as bright as the other one, it's still a million times brighter than the sun.
Of course, Eta Carinae is also pretty far away from us. It's thousands of light years away from us. So, yeah, of course. All
Wow,
right.
so that means when we saw the eruption back in the 19th century, it took thousands of years for that explosion
Yes.
to travel, right? And when we
Yes.
saw the explosion, it happened many years ago.
Imagine when it first exploded, there were still mammals running around on Earth.
Yeah, amazing. Yeah, that always amazes me. Do you have one more
Oh,
photo?
yes, I believe we have got one last image. There it
There
is.
it is. Yes.
We are back again to what we saw earlier.
So this is the one that was close to which constellation again, Young?
That was in the constellation of the Southern Cross, the
Yeah.
Crux.
Yeah, this is the one close to Mimosa, right?
That's right. And
So
it's one of
this
my
is
favorite one.
what is this? What are we looking at right now?
So we are looking at, if you would see, right, there's different colors over there. So this is what we call the jewel box star, yeah, the star cluster.
I
And you
see.
can see there's red. You can, with a bit of imagination, see a bit of bluish color, maybe even, I don't know, green. Well,
Yeah,
different
yeah.
shades of blue.
I can see different shades of blue. It does look like a jewel box with some sapphires and maybe I don't know if it's just me or is it really red, one of them in the middle,
Oh, yes,
right?
that is red.
It does look red, right? It looks like a
Yes,
ruby, and that's why it's
yes.
called the jewel box. Really pretty when you look at it through a telescope. And the amazing thing about this jewel box, and again, it's young because it's still within a cluster. And by young, we mean just a few million years old. This one is 14 million years old, which again sounds like a long time for us humans, right? But it's actually human of the universe, rather.
Mhm.
So this one is 14 million years old. It's about the age of the Philippine archipelago. I asked my geologist friends earlier today, I said, about how old is the Philippines? And the answer is not easy to come up with because different parts of the Philippines were formed in different times. But most of the Philippines started forming somewhere between 28 million years ago and 12 million years ago.
Wow.
Yeah, so fairly young. That's why we don't see a lot of dinosaur bones here in the Philippines because most of the islands of the Philippine archipelago formed around that time, between
Mhm.
28 million years and 14 million years, 12 million years ago. And the jewel box is only 14 million years old. So about the same age as most of the Philippines.
Of course, like when we're talking about cosmic time scale, we are talking about billions of years. Like
Yeah.
our sun is like a 4.6 billion years and is still considered to be a middle-aged star right now.
Yeah, that's right. It is a middle-aged star, so it's gonna go on for a few more billion years before it's gonna go red giant, right? So I
Mhm.
believe, Young, we have a question
All
from
right, the question.
Facebook. Yeah. So a question. is from Jasmine Ann Rivera. And her question is, where's the best place to do stargazing in the Philippines and Singapore? So let me start young with the Philippines. So one would be when you're near Manila, one would be Tanay Rizal, as I mentioned earlier. It's a little bit higher in altitude, higher from sea level, and it's also further away from Manila, so less light pollution. So it's really good to do stargazing there. But one of the best places I've been to that's really excellent at stargazing, aside from mountains, mountains are really, really good. Like if you go to a part of the Philippines we call the Cordilleras, where we have lots of mountains, right? When you go up to the mountain, you see really wonderful views of the sky. So aside from that, the other place that I was surprised that the sky was so good was in El Nido, in a part of the Philippines we call Palawan. The sky was just so wonderful. I was in the middle of the town, El Nido, and there was some light pollution. I was in the middle of a market, a well-lit market, and yet I could see so many stars. It was fantastic. How about you, Young, in Singapore?
Singapore is comparatively much smaller than the Philippines, so there are very few places for us to do stargazing and such. But some of the more nicer place to do it is, where I've done it, is probably the St. John Islands. So if you ever travel to St. John Islands by the Marina South Pier, travels over there, there's a Lazarus Island chain over there. So because it is relatively less, how to say, inhabited, it is how to say the light pollution there is much better. So from there you can see the sky looking very clear. So
Yeah.
unfortunately, there is still a little bit of light pollution from Singapore since we are in the southern coast of Singapore, but it's still much better than many other places in Singapore. Also, if you like to travel to some of the other more isolated area like Chua Chu Kang, you might actually also have a nice view of the night sky as well. So unfortunately, Singapore, there is not so many places. Oh, there's Pulau Ubin as well if you manage to get there. So you can go to Pulau Ubin, which is an island in Singapore. That's a little bit more towards the northeastern part of Singapore as well. And where else is that? Oh yes, I believe right. If you join TASOS, that's the Astronomical Society of Singapore, they also occasionally travel off the coast of Singapore to this place called Semakau Island. So yes, have you noticed something strange about all this stargazing
Yeah.
in Singapore that they have mentioned? They're
Yeah.
all islands, right?
Yeah, that's right. Yeah.
Yeah.
Yeah,
So
and speaking of what you can see in Singapore, Young, I'm looking at a feed right now. Is that
mhm.
from Singapore?
Oh yes, I'm actually looking at the night sky in Singapore right now.
So this one, what is that? Is that this? It says Regulus. Is that taken from a telescope?
Regulus. Oh yes, I believe this is the live casting of the
Live
view.
casting. I
Yes, that's
see.
right. So remember, we saw Regulus, which is a star within the constellation of Leo the Lion.
Yeah.
And by the way, right, you all notice that Regulus, the star over there, is
Uh
kind
huh.
of like a flickering and
Uh huh.
twinkling as well. That's
Yeah.
how you can differentiate between stars and planets.
I see.
Because stars, right, they're more like a singular point of light far away
Yeah.
from us, many light years. So as that point of light travels through the atmosphere, it starts
Uh
to
huh.
waver and move around and twinkle.
Yeah, and because they're really
Kind of,
far, they almost appear like a point of light, a point source of light in the sky, right? So the merest disturbance from the atmosphere will make their like falter and flicker, right? Which is why they appear to twinkle in our sky compared to planets, for example, which are relatively nearby and therefore don't appear as pinpoints of light. They appear as little dots, very little dots, right? You need a telescope to see that they're not dots, but they're still not pinpoints of light, right? And that's why they don't appear to twinkle. So I see Regulus. What kind of telescope do you have there to show this, Young?
I believe this is a 5-inch Schmidt Cassegrain telescope.
I see,
So
yeah.
that's so I believe right what we have is this probably Lee Fei. Actually, she's one of our science educators as well, operating the telescope off-site,
Uh-huh.
training it at a star over here and trying to give us some view of the night sky.
Cool, that's cool. Yeah, a 5-inch. Actually, for those who are not familiar with telescopes, a 5-inch Schmidt Cassegrain telescope. It's a kind of telescope named after people who tried to discover to invent it. It's a really clever telescope. We astronomers, especially we amateur astronomers, really love it because it's not big and bulky. It's a handy telescope that you can. Some people I know put it in their backpacks even. That's how handy it is because it uses a combination of mirrors and lenses to more or less fold the telescope, right? So it's almost like a folded telescope in an optical sense, so that instead of being like this long, it becomes half as long because it's folded in. And even with a fairly modest telescope, like a 5-inch Schmidt-Cassegrain telescope, or SCT for short, or like what we have in the museum, a 6-inch SCT, you can see really bright things like Regulus, right? You don't need to go to the really dark places that our audience asked, right? In order to enjoy them. Like, what else, Young, are you able to see there with your telescope in Singapore? Like, what bright objects in the sky?
What bright objects can we see in the night sky?
Yeah,
Well, we
with your
could
telescope.
actually we could try to look at Betelgeuse if it's high up in the sky and if it's clear. But really, when we look at the night sky, it is really entirely up to what is up there. So I
Yeah,
can't promise what we could see tonight because it might be very cloudy in certain
I
regions of the
see.
sky, or
Yeah.
perhaps Sirius would be a good candidate to look at as well.
I see. But if the positions are like possible, are you able to see? For example, we don't see them right now because they're not yet in a favorable position in our sky. But when they happen to be in a favorable position in the sky, are you able to see planets like Venus and like Saturn and Jupiter in
Oh
Singapore?
yes, of course. If they're out there, it is always something that we try to look for. But Venus, right now in Singapore, it might be a little bit too low for us to see. So it's almost 9 p.m. already,
Yeah.
and it might be a bit too low. So just now we didn't have a look at Venus, but for those who are interested, Venus is a planet, okay, the closest planet to Earth right now, and it can be found in the western part of the sky. So if you look towards the west, where the sun sets, right, usually around 8 p.m., around 8:30, you see this super bright star-like object, but not twinkling. That is not a star. That is the planet Venus.
Yeah. Yeah, a lot of Filipinos see it here too in their sky, and they ask me like, "What is that bright star?" And I tell them, "It does not twinkle, doesn't it?" And that's a hint that it's not a star. It is actually a planet, right? It's the planet
Okay.
Venus, yeah, which is really bright. So bright that in the Filipino language we have a separate name for it. Like most stars are called bituin. That's the Filipino word for star. But these really bright things that look like star, they have a special name for them. They're called dala.
Dala.
So yeah, and now we know that they are actually planets. Back in the day, astronomers did not know. Like for example, the Greek astronomers, they did not really know that the planets were rocks in space, right?
Yes.
So they just called them planets, which in the Greek language was planetos, which means wanderer.
Yeah.
So they just call them because they're not always in the same constellation in the sky. They change places in the sky.
All right. Now, early on, Pecier, we talk
Yeah.
about one of the stars within Virgo, right? We say spike over to Spica. I think we might be able to try to get a
that
view
would
of
be
the
cool,
star
yeah.
Spica as well within the constellation of Virgo.
Virgo, yeah. And again, a reminder for those who were here earlier, you can do a little bit of star hopping from the Big Dipper all the way to Spica to find Spica, right? So you look for the arced handle of the Dipper, right? It's not straight, but it's arced. So we say it arcs to Arcturus. That leads you to the bright star Arcturus. And then you speed on to Spica, or you spike to Spica. And that will take you to Spica, right? Or Spica. Right.
I don't know
Alright.
how to pronounce that.
Same here. All right, yeah. In fact, a lot of the stars, they have either Greek names or Arabic names, right? So back in the day, when I was reading, I thought it was pronounced Altair. And then I only recently discovered it's Altair, right? Because its name was based from Arabic names. So many stars have Arabic names.
Well, do you learn the pronunciation from playing a game called Assassin's Creed?
Yes, that is true. When I describe the name of the star to my audience in Manila, you could see the reaction of those who've played the game Assassin's Creed, the look of recognition. And I like that when there's that note of recognition. For example, when I talk about Sirius, the dog star, and the fans of the Harry Potter book series recognize the name, or those very deep fans. In fact, when I talk about the star Regulus, right, which is the heart of the lion, I mean, those very deep Harry Potter fans would recognize, oh, that's another character from Harry Potter called Regulus, and he turns into a lion in that fictional universe. So it's wonderful that even in these stories, in these fictional stories, we can have, oh, there you
Yep,
go.
I can see that right now. It's a bluish colored
Ah,
star.
yeah. Bluish colored star Spike or Spica. I
Mhm.
see. That's cool. Yeah, and if it's based on Greek, it would probably be Spica because there's no long I in the Greek alphabet, and that's why I often remind people that the name for that moon of Jupiter, one of my favorite moons in the solar system, the most volcanic place in the solar system, can be pronounced Io, right, instead of Io, the one
Yeah,
that's just spelled I and O. That's the moon, one of the moons of Jupiter. So Spica, that's so cool.
pretty bright.
Yeah.
And you know,
Okay. Wow, that's so cool. Right. So, Young, do you have any more to show our audience, or are we ready to wrap it up and encourage them to look up on their own?
well, I think that it's almost time for us to end our show and allow the audience and have an exploratory part of their night
Yeah.
viewing as well. So if that's right, we've almost come to the end of our show. So on to you, Isha.
Okay.
Do you have
So,
anything?
yeah, so I'd like to thank you, Young, and your colleagues there at Science Center Singapore for inviting me to be a guest host here. It's been a pleasure to talk about the sky from here in the Philippines and to learn about the differences between our sky that we can see here in Manila and the sky you can see in Singapore. And it's been a pleasure introducing the things that you saw there in your telescope and that you have photos of to our audience. So again, thank you very much for that. For the rest of the audience, again, I'm Pecier Decierdo from the Mind Museum, and I'm inviting all of you to please follow us on Facebook and Instagram so you know when our next programs will be. Many of our programs are already online, and more of them will be online in the future. We're working on more. But one program that we have right now that's regular and online is what we call our Mind at Home series. So just this Wednesday, I did a Mind at Home series about the phases of the moon, how you can learn about the phases of the moon using cookies and using an orange and the flashlight, using materials you already probably have at home. And the next one will be on May 11th, that's a Monday, and they happen every Monday and Wednesday. So if you'd like to be updated on when the next one will be, please follow us on Facebook and watch the previous sessions of Mind at Home as well, where we introduce activities that are not just about astronomy. Some of them are about astronomy, but some of them are about chemistry, some are about physics, right? Things that you can learn from and that you can do at home during this time where we're asked to stay at home. So thank you very much.
All right, it's our pleasure to have you over here, Pisha. And I will visit you in Manila when we can, okay, when the situation gets better.
Yes,
All
I'm
right,
looking forward to
so
it.
yeah. So, ladies and gentlemen, boys and girls, I hope you enjoyed what we have, our givings over here. So, do explore Stellarium for yourself, or look up in the night sky from your balcony and see if you can see what we have described just now in the night sky. And so that's all right. Let me end our show. So, stay home, stay safe, and keep looking up. Bye bye.